Data link layer receives data packet from network layer. Data packets contain IP addresses of sender and receiver. There are two kinds of addressing, logical addressing and physical addressing. Logical addressing is done at network layer, where sender and receiver's IP addresses are assigned to each segment to form a data packet. Physical addressing is done at data link layer, where MAC addresses of sender and receiver are assigned to each data packet to form a frame. MAC address is a 12-digit alphanumeric number embedded in network interface card of your computer by your computer manufacturer. Data unit in data link layer is called frame. Data link layer is embedded as software in network interface card of a computer and provide means to transfer data from one computer to another via a local media. Local media includes copper wire, optical fiber or air for radio signals. Please note, here media does not correspond to audio, video or animation. It refers to the physical links between two or more computers or networks. Data link layer performs two basic functions. It allows upper layers of OSI model to access media using techniques such as framing. It controls how data is placed and received from media using techniques such as media access control and error detection. Consider two distant hosts, a laptop and a desktop, communicating with each other. As laptop and desktop are connected to different networks, so they will be using network layer protocols, IP for example, to communicate with each other. In this example, desktop is connected to router R1 via an Ethernet cable. Router R1 and R2 are connected via a satellite link, and laptop is connected to router R2 via a wireless link. Now, desktop wants to send some data to laptop. Based on the medium used to connect desktop and router R1, data link layer adds some data in the head and tail of IP packet and converts it to a frame, Ethernet frame in this case. Router R1 receives this Ethernet frame, decapsulate it to an IP packet and then encapsulate it again to a frame so that it can cross satellite link to reach router R2. Router R2 will again decapsulate the received frame and encapsulate it again to form a wireless data link frame. Laptop receives this wireless data link frame, decapsulate it and then forward IP packet to network layer. Finally, data arrives application layer. Application layer protocols then make the received data visible on computer screen. So, network layer or higher level layers are able to transfer data over media with the help of data link layer. That is, data link layer provides access to media for higher layers of OSI model. Data link layer also controls how data is placed and received from the media. The technique used to get the frame on and off the media is called media access control. There may be a number of devices connected to a common media. If two or more devices connected to same media send data at the same time, then there may be a possibility of collision of the two messages, resulting in a useless message that neither recipient can understand. To avoid these situations, data link layer keeps an eye on when the shared media is free, so that device can transmit data for the receiver. This is called carrier sense multiple access. So, data link layer with its media access control methods controls data transmission. Tail of each frame contains bits which are used to detect errors in the received frame. Errors occur due to certain limitations of the media used for transmitting data. The last layer is physical layer. Till now, data from application layer has been segmented by transport layer, placed into packets by network layer and framed by data link layer, which is a sequence of binary zeros and ones. Physical layer converts these binary sequence into signal and transmit over local media. It can be an electrical signal in case of copper cable or LAN cable, light signal in case of optical fiber, and radio signal in case of air. So, signal generated by physical layer depends on the type of media used to connect two devices. At the receiver, physical layer receives signals, convert it to bits, and pass it to data link layer as a frame. Frame is further decapsulated as data moves through higher layers. Finally, data is moved to application layer. Application layer protocols makes the sender's message visible in the application in the receiver's computer screen. In this way, OSI model is helping to transfer data between distant hosts. So, These 7 layers of OSI model are lying behind the smooth functioning of internet. If you have learned something from this video, then please like this video. Share this video so that more people can learn. Subscribe to Tech Terms if you want to learn more and turn the notification icon on. Thanks for watching.